So I'm Scot Schultz. I'm from Mellanox. I'm a director of HPC in AI, on technical computing. I've been with Mellanox now for about 7 years, so very familiar with what we're doing in our roadmap and where we're going. At least I think I am. And so what I'd like to start out is by just saying, like, from the very beginning, right? Mellanox has kind of had our ear to the ground. We've been very attentive to the developments of the technology and the CPUs and GPU technology, and really what I'm focused on is the interconnect needs and what we need to satisfy, keeping those GPUs and fast CPUs and whatnot working very hard. And so, Mellanox products they're proven, they're resilient, they're very much hands down the most widely used and most widely adopted products for high-performance computing and AI, as well as in hyperscale and cloud computing. So for generations, Mellanox has been, connecting to the world's most visionary research and scientific discoveries, and we're very proud of that. And I believe that we have a very clear vision for tomorrow, and we understand where the industry is going and the needs of tomorrow. Now, before I jump right into the presentation, there's always an update on the top 500. And this year, or at least this November, the top 500 didn't really change a whole lot. And Mellanox continues to enjoy the number 1, 2, and 3 spot, as well as the number 5 spot at TAC, which is actually based on HDR. So HDR is getting quite a rapid adoption. We've probably seen more adoption in the last 6 months than we've ever seen across all the generations of InfiniBand since the beginning of SDR and DDR. And who remembers SDR and DDR? InfiniBand. Wow, cool. And so we've managed to capture the number 5 spot already with HDR, and we expect, and I think we've seen about 14 additional systems since June, so that represents about 12% CAGR year over to year. And so we're getting very significant traction with HDR and InfiniBand. HDR being 200 gigabits a second, and so just so that you know, and if you don't know about anything that I'm talking about, please raise your hand and ask me a good question. So really, this is basically a snapshot of our product portfolio. We basically have always provided the industry with our adapters. So we have from adapters, switches, and transceivers. But a lot of people are not familiar with our Smart NICs, or what's called the product's called Bluefield. And Bluefield is a relatively new product. It doesn't really compete with the bigger cores. But for security, offloads, NVMe, storage, and these types of things, Bluefield is being very, very pervasive. And Bluefield is basically an SoC. It's a complete system on a chip. It has up to 16 A72 ARM cores, coupled with our interconnect fabric, and it also has integrated security and these types of enhancement, NVMe, and all of our associated offloads. And so you can see that in the Mellanox booth. But I'm not going to spend a whole lot of time on Bluefield as much as I'm going to talk about our new products that actually complement our solution and our portfolio. The first of them being Mellanox Quantum Long Reach. And long reach is fundamentally extending InfiniBand out to 40 kilometers. And so if a lot of you maybe remember a product called MetroX, where we're also be able to extend out InfiniBand, but that was done at QDR and FDR speeds. So this service is HDR and EDR. It also supports all of our goodness around in-network computing or sharp capabilities. And for scalability and load balancing across the data center, this is really, really a very cool and unique product. Another use case might be, you may be working in a lab on a workstation, and hopefully you'd have an InfiniBand card in there that you could hook up to this long haul. And maybe the data center is really across campus, right? And so, but back in the lab, you're just kind of tweaking and tuning your algorithms or whatnot, and doing your test runs, and then you can immediately kind of deploy it right into the to the data center backend with your InfiniBand fabric. So this is really, really a cool new product. Our second new product that a lot of customers have been asking us for is, hey, what happened to that really cool switch that you had that we could bridge InfiniBand over to Ethernet? Because we can only do that now at 56 gig. So they've been asking us when you can have this ready and available, and so we've developed this 2U appliance. It's called Mellanox Skyway. It's going to host the Mellanox Gateway operating system, and so it'll be a really self-contained device, all completely managed, being able to support EDR as well as HDR 200 gigabits a second today. But what's really cool is, you know, very easily it's NDR and XDR 800 gigabit ready. So we think that so many customers have asked us for this, that we brought it back, and it's going to be a very cool 2U appliance, and I believe it'll be available in the beginning of the year. So we've had a lot of attention around Skyway. You can visit the Mellanox. Uh-oh. My PC has ran into a problem and it gave me a sad face. Okay, so while we're going to try to reboot that thing and continue on, let's see if I can remember my presentation, because or actually, how about some questions? First of all, does everyone know what InfiniBand is? Yes. Does everyone love DDN storage? Pretty cool. Has everyone heard of the new stuff that's happening with DDN and what's called, well, it used to be called GPU Direct Storage. Now it's called, what's it called now? Yeah, I'll have to remember the name because they just changed the name. But the methodology of being able to move data directly to the GPU. Very similar to our technology, which is called GPU Direct. Magnum.io. Yes, so we're working on a lot of really cool technologies with DDN, as well as NVIDIA, as well as other partner industries. And basically part of the message and story behind Mellanox is that basically everything that we do is really around co-design. We work with our partners and our end users and our customers. It's not like we just go off and build it and then say, we think you guys can use this. We basically listen to what you guys need and our end users and kind of what your obstacles are, and then we work with you to help develop that. And if you have problems or software based only kind of issues, we can actually work with you to actually develop more additional hardware offloads and bring that into the silicon for our next generation. And so we're very aggressively working within the industry, and including Dell and DDN.
Right, if it gets trying, it's still in this loading process.
You. Yeah. And maybe while they're bringing that up, I'll just jump to the slide where I'm going to show you a 4-pillar approach to kind of what Mellanox is investing in. And I'm going to basically start at the very bottom layer, which is really all about the hardware, right? So we've implemented these things which kind of gives us connectivity between bridging between Ethernet as well as InfiniBand, and we have technologies like multi-host and socket direct to help extend the life of Gen 3 platforms so that you can actually drive HDR 200 gigabits a second. And we're also very focused on, at that connectivity layer, various topologies, whether it be, Fat Tree or, we have a very popular Dragonfly Plus now that has been adopted over several installations over the last few years. But it doesn't just stop at the connectivity layer. We have many engineers that are basically focused on delivering on the connectivity layer as well as the transport offload layer. So that's working on things like GPU Direct and GPU Direct RDMA. Working on things like the Magnum.io solution, bringing faster acceleration offload engines to market, being able to bring those things into light. Our adapters have many features like tag matching that's now done in hardware versus software. And then fundamentally working on Sharp, which is the element of in-network computing. So our fabric and our switches have the ability to actually do data aggregation and data manipulation on the data as it traverses the network. And that's the fundamental concept behind what we're doing as far as, oh, what slide am I on?
I'm not on the reception. You're back at the beginning, so where are we going to fast forward?
Well, we're going to fast forward to bing, 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 bing. Maybe we'll just start here. No, let's just start where we were. Okay, we covered the connectivity layer. So we talked about the various topologies, if it's Fat Tree or Dragonfly Plus. But then we start talking about the network transport offload layer and the communications layer, where we have literally hundreds of engineers that are completely focused on delivering these kind of features. So GPU Direct, which is the ability to move data directly from a GPU to another remote GPU across the InfiniBand fabric, without having the CPU involved at all, is one of it's been heavily adopted across not only the world of HPC, but of course AI and machine learning. And I'll talk a little bit more on that, kind of what we're doing. We also have Shield, and Shield is a kind of this autonomous self-healing network. So if your data is traversing the fabric, let's say you're running a very, very large workload, and you know what? Someone's back there in that data center, and someone tripped over a cable and pulled that cable out, and you know what? It doesn't matter, because our fabric is intelligent enough to actually monitor ports, look at the kind of fabric, and we'll actually reroute the data automatically for you. It's all handled in the hardware. There's no sticky, messy software at all to take care of. And we'll reroute that data and get it to the destination and this happens in real time. And so what that means is fewer checkpoint restarts, less and fewer job interruptions that may cause you problems. Taking a look at HPCX and UCF and Sharp, all of these core features and capabilities that we enhance to the InfiniBand fabric is kind of what we're focused on. And how does that translate into kind of real-world applications or real-world feedback? So Oak Ridge, which remains the #1 on the top 500 right now, using Mellanox adaptive routing, another core feature that's actually handled in the hardware. They're able to achieve 96% of network utilization. And when I'm talking about Sharp, being able to do data aggregation and being able to do data reductions and such at the switch level, if you take a look, there's the #1 system in Canada, which is called Niagara, is getting 7x higher performance by taking advantage of Sharp. And that's even for the smaller messages. This actually is a kind of another example showing the differences between if you are doing all reduce in the hardware versus the software. So as you add more compute elements to your cluster, right, Sharp helps you maintain a very predictable, very ultra-low latency. And if you were to do it in software, you could see that even at 128 nodes, right, your latency just starts to dramatically increase. And so that's really a core benefit of Sharp. And really how that translates to what we've done in the HDR quantum switch, the 200 gigabit switch, for AI is it's going to fundamentally give you 2x higher performance. So the switch now can actually fundamentally replace a parameter server because all reduce is the fundamental kind of function of doing the gradient descent operations, right? And so if as the worker nodes go and do their compute, and the gradients the averages of the weights are sent up, and then the switch does the gradient operation and kind of broadcasts back down to the workers so that they can continue the next epoch. And this really is going to give you a 2x performance benefit. And so I like to use all reduce as an example, but if you stop by the Mellanox booth, I'll show you other things like Facebook's autoencoder. I got some NLP examples of how we're actually taking Sharp, marrying it with the NVIDIA Nickel library in order to give you kind of transparent performance. How am I doing on time, considering?
Good question.
Good?
I don't even have a watch on me. Let's see.
So we talked about Shield, but also, in the cloud. So HPC in the cloud. So Microsoft really depends on the Mellanox solutions, and they can actually show a 13x higher performance over other cloud providers that are kind of still stuck on their old in-house kind of Ethernet stuff, right? So InfiniBand, even for cloud HPC, is really pervasive, and and fundamentally 13x higher performing. Okay, so how does this translate? So I talked to you about we're doing a little bit of work with NVIDIA around Sharp and AI. So what we're doing is we're developing a plugin. It's a very simple, easy to deploy plugin, and when you have Nickel installed in your for your AI frameworks, I have Cafe 2 listed here. I'm embarrassed. I should have taken that one off. But what we'll do is this plugin will be completely seamless, and the Nickel library will see that you have the plugin installed and that you have the Mellanox fabric, and it'll be kind of transparent to you. It'll be very easy to deploy. And so we're very excited to bring that. That should be available around the December timeframe. And in the Mellanox booth, we're going to show you a few other examples across other workloads. Okay, so as I wrap up, for all these reasons, right, InfiniBand really delivers the highest performance and ROI benefits because we have native RDMA. We have a very extreme ultra low latency and extreme high bandwidth. And we continue, and we're not stopping at HDR, right? So we have a very clear roadmap that goes beyond HDR into the NDR 400 gigabit time frame as well as the 800 XDR gigabit time frame, which is not that far off. It's actually closer than you think.